Howdy, PreCal. It's Miss Kosh. I am going to work through part of the notes for today. We are looking at dividing polynomials and finding roots. So I assume that you've seen this before. If not, let me know. But I'm going to teach it like you've never seen it, just a whole lot faster. Okay, so when dividing polynomials, it is always possible to use long division, but synthetic division is most efficient when dividing by a linear function. Okay, I could always divide anything by long division, but it's a little more tedious. So as a reminder, with synthetic division, that's what we'll use in this first one. This one, it's missing an x cubed term. And you'd need to take care of that if you're using synthetic division or long division. But what you'll do, I think I draw my box a little bit differently than the books or the Algebra 2 teachers, but it's fine. We're going to take the coefficients. So I have 1x to the fourth. I have 0x cubes. I have 3x squared, negative 5x, and then my constant here is 2. And since I'm dividing this right here, this is my factor. I need the corresponding root. Okay, so factors always have x in them. Roots are what you would get if you set that equal to 0. So if x minus 5 is a factor, you set that equal to 0, then that means that 5 is a root, a 0, an x-intercept, call it any of those three things. But this part right here, this is the factor, this is the root, or the 0, or the x-intercept, but you can call it any of those three, you just can't call it a factor. Okay, that being said, we're going to take the root or the 0 and put this on the outside, and then just a reminder, we bring down the 1, multiply that times 5, add them up. That gives us 5 times 5 is 25. This is going to get gross. I'm going to forget how to multiply very shortly. 140, this becomes 135. I don't know that I care at this present. You know what? There's a calculator right next to me. I'm sorry. I only have so much emotional energy this year to care about certain things. So this is, sorry, it's the reality of the situation. Okay, and so this last one right here, this becomes, yeah, actually that's the month and year I was born, but okay, whatever. Okay, so this would tell us if we divided, what we end up getting, when I take I'm on a different color. When I take a quartic and divide it by a linear, notice that's got a degree of 1, then a quartic divided by a linear is going to now give me a cubic. And so my final answer, sure enough, this is I have the remainder, I have the constant, I have the x term, I have the x squared, and I have the x cubed. Okay, that got a little messy. So that's our final answer. This becomes 1x cubed plus 5x squared plus 28x plus 135 plus there was a remainder of 677 over, well, what were we dividing by? We were dividing, that's a mess, we were dividing by x minus 5. And that's our final answer for that problem. Okay, the next one we have to do long division, and so on each of these I'm going to say, okay, the first one, I have 2x cubed. I'm going to think of, okay, what happens when I divide that by the very first part? Well, what I'm dividing by, I'm sorry. Okay, this would be 2x. So I like to be very picky. I like to keep everything in lovely columns here, okay? If it has an x, like on this one, I'm going to put that 2x, I'm going to put it in this column with my x's. So that way everything is lined up and nice and beautiful, and I don't get lost in the details, or I'm less likely to get lost in the details. So then I multiply that back and I get 2x cubed. If I don't get exactly what I had here, well then we're going to have problems. So and then this becomes plus 10x squared, and then I get plus 4x. And then as you remember with long division, you subtract. Okay, that gives me, the x cubes are gone. I now have 3x squared and plus 15x plus 6. And so now I'm going to look at that and say, okay, well, what's 3x squared divided by that original x squared? Well, that's 3. And notice my columns are very intentional. I do that on purpose. So when I multiply back, let's pick a new color, I get 3x squared plus 15x plus 6. Oh, we got lucky. That all cancels out, leaving me nothing. And so the final answer is this 2x plus 3. Okay, so the next thing says the remainder theorem is the next thing we want to talk about. And the remainder theorem states that if a polynomial is divided by a linear factor, then its remainder is, okay, so if f of x is divided by x minus k, then the remainder r is f of k. Okay, so for example, if I had, when I divided, nope, I don't want to do that one. Okay, if we look back up here, when I divide this original problem, when I divide that by, my brain just stopped. When I divide it by x minus 5, I'm sorry, then I get a remainder here of this 677. Let's look and see in Desmos. What was it? It was, I want to plug in, where did it go? I want to plug in 5 to x to the 4th plus 3x squared. Okay, so I have 5 to the 4th plus 3 times 5 squared. I just forgot it. Oh, that's what I need. Minus 5 times 5 plus 2. Minus 5 times 5 plus 2. Oh, sure enough, that gave me the correct answer. Thank goodness. Okay, so what happened, what I just showed you, is that if this had been my f of x, if my f of x up here had been x to the 4th plus 3x squared minus 5x plus 2, that f of 5 was equal to that 677. That's the remainder I get when I divide by x minus 5. So these numbers here end up being the same. So you can decide, is it better to get there? On each of these, you get to make the decision. Am I better off plugging it all in? Well, in that, it was going to be kind of gross, and I used Desmos to help me. Or am I better off finding that number with synthetic division? It works out the same way either way, which is kind of cool. Okay, so this one says, what's the remainder here? Well, I don't really want to plug in -2 and try and figure this out, so it might be better off to come along and say, well, let's do synthetic division with -2. So it's 3 times -2 is -6. Okay, well, that makes that number smaller. That's good. 2 times -2 is -4. That makes that 1 times -2 is -2. My remainder is -9. And I think that that was an easier way to get my remainder. Well, I could have plugged it in. So anyway, I guess they wanted me to plug it in. Oh, well, usually you have a choice of doing it whichever way you want. So there's that. Okay, moving on. So next thing we want to look at, oh, you know what? I pulled up the wrong form. Okay, I'm going to make a second video. I think we're fine. The notes look we changed the notes, and I have the wrong thing in my notability. But we'll be fine. Just come back and look for the second video. All right, see you later.